Hello students. So today we will discuss our next topic, which is feedback in amplifier. So I hope now we all are aware of what is an amplifier. So it is an electronic circuit where we have input and output. So when the fraction of the output signal of an amplifier is feedback to the input circuit, this process is called feedback, and the amplifier is called as feedback amplifier. Okay, and this feedback to the amplifier, it can be positive or negative. And what do we mean by this positive and negative feedback, that we'll just discuss. So positive feedback, positive feedback means when the feedback signal which is fed back to at the input, if that fraction of output which is we are feeding to the input is in phase with its input. Okay, if that output fraction of the output which is feedback to the input is in phase, same phase में अगर वो है input की, then that feedback is called as positive feedback or regenerative feedback. Okay, so the positive feedback increases the gain of the amplifier, but due to increased distortion and instability, it is seldom used in amplifier. Okay, so this positive feedback both has advantages and disadvantages. Advantages, the gain of the amplifier will gets increased, but the distortion and instability also gets increased, which is disadvantage of this amplifier. Okay, and in general this positive feedback is used in oscillators. Okay, and what are the oscillators, that we'll discuss in our next unit. Okay, so this is the diagram where you have seen what is this. Suppose this is our input signal, and corresponding to this input signal, okay, the a part of output is fed back to the circuit, so that the resultant signal will be like this. Okay, here you have observed one important thing, which is, see, in this figure, both input as well as this feedback signal both are in same phase. Same phase means for the positive half cycle we have positive, and for negative half cycle we have negative. Okay, and uh, resultant of both these will be like this. Okay, then we also have negative feedback. Negative feedback also, as its name suggests, means when the feedback signal which is feedback at the input is out of phase of the input. Okay, if the phase of input and the feedback signals are both out of phase, means if it is 180-degree reverted. Okay, so in that case this feedback is known as negative feedback or degenerative feedback. Okay, the wave signal will be like this. Okay, here we have input signal, as you can see. Okay, input signal like this. Okay, and output signal is like this, means which is 180-degree out of phase with respect to the input. Okay, and corresponding to that we'll get our resultant like this. Okay, so this kind of feedback where the feedback signal has out of phase, means 180-degree phase reversal in with respect to this input signal, is known as negative feedback. Okay, and again this negative feedback also has many advantages and disadvantages, but it has more advantages than the disadvantages. The first advantage is it reduces the amplitude distortion. Okay, it reduces frequency and phase distortion, noise in output. It increases the stability of gain. It improves input and output impedances, and also it increases the bandwidth. Okay, all these are the advantages of this negative feedback. Okay, and due to these advantages we generally use negative feedback in amplifiers. Okay, and we'll do discuss all these advantages one by one in our next lectures. Okay, so now we'll come to uh, this part, which is theory of feedback, how this feedback thing works in a transistor amplifier. So the basic principle of a feedback amplifier can be explained on the basis of this diagram. Okay, where you have seen we have this amplifier circuit whose voltage gain is A, and we have this input voltage uh, Vi and output voltage V0. So what we have done, as per our definition, we have taken a fraction of voltage in the output, means uh, this part. Okay, here we have picked up a part of output voltage, okay, or output voltage through this feedback network. Okay, a feedback network is the network which will use this much output voltage. Vf is beta times v0. Okay, so this fraction of the output voltage will be again given in the input. Okay, so this is the block diagram of feedback amplifier. Okay, and now we'll discuss its working. So let us consider, let A be the voltage gain of the amplifier without any feedback. Okay, so in that case, what will the voltage gain? It is simply V0 by Vi, output voltage by input voltage. Okay, and this gain is often called as open loop gain. That means when there is no feedback. Okay, so that time the voltage gain will be A is equal to V0 by Vi. But when we use this feedback network is connected, in that case a fraction of voltage which is Vf will be beta times V0. Okay, and you need to remember, do remember, this beta is not the current gain. Okay, which is in case of common emitter. Okay, and whose value is about 100, that is the current gain in case of common transistor. But this beta is another factor. Okay, as we are saying a fraction of output voltage, so with that it should be clear, the beta has to be less than 1. Okay, a fraction of output voltage is fed back to the input. Okay, and this ratio, the feedback ratio, which is Vf by V0, is your beta. Okay, so with feedback circuit, the effective input voltage will be, how much effective voltage will be, this will be this value. Vi will be Vs plus Vf. Okay, Vs is the voltage signal and Vf is the feedback signal. Okay, and Vf we have considered it is beta times V0, so this will become Vs beta V0. Okay, so and from equation 1 for the open loop gain, from this we know V0 will be A times Vi. Okay, now substitute V0 here. Okay, so this equation will become this, V0 will be A into Vs plus beta times V0. Okay, so further, by solving further, this will become A minus 1 minus A beta V0 is equal to A Vs, or the voltage gain of the feedback amplifier. Okay, with feedback, this voltage gain will be known as AF. Okay, this voltage gain will be known as AF, and with feedback, now what will be the output voltage? V0. Okay, and what will be the input voltage? It is Vs. Okay, so the ratio V0 by Vs will be this. So now find out this ratio from this equation. Okay, from this equation find out V0 by Vs. It will be nothing but A by 1 minus A beta. Okay, and it is nothing but the AF. Okay, so the voltage gain with feedback will be this, AF will be equal to A by 1 minus A beta. Okay, so in figure on last page, if you remember, okay, from this figure, the feedback voltage Vf adds to the signal voltage. Okay, and therefore feedback is positive. Okay, so here we have used uh, positive feedback, and due to that only we have considered this signal like this, means this Vi input signal will be Vs plus Vf. This we have considered. Okay, so and because of that our feedback gain will be this. And if this feedback is negative, okay, so in that case this Vi will be this value, Vi is equal to Vs minus Vf, because the feedback voltage is negative in opposite phase. In that case, when we solve this equations, in so in that case our final result will be this value, AF will be A over 1 plus A beta. Okay, so the case of positive feedback, gain will be this, and case of negative feedback, gain will be this with feedback. Okay, so these two value you need to remember. Okay, so now we do discuss some special cases. Suppose if we have this value, if 1 minus A beta is less than 1, mod of 1 minus A beta is less than 1. Okay, so in that case, if it is less than 1, then we know this AF, the voltage gain with feedback, will be much higher than the open loop voltage gain. Okay, and this is the scenario of positive feedback. Okay, because we have used 1 minus a beta. Okay, so the polarity of the feedback voltage is same as that of the input, and vi is equal to vs plus vf. And if this 1 minus a beta, second case, if 1 minus a beta is much greater than 1, in that case af will be less than a. The feedback gain uh, will be less than open loop voltage gain. So in that case, this is the case of negative feedback. Okay, and the polarity of the vf is opposite to the input, so in that case vi is equal to vs minus vf. And third case, suppose if we have a condition where a beta is equal to 1, so in that case 1 minus a beta will become 0, and that means a will become infinity. Okay, and this means that output can be obtained even without any input because we have infinite gain. Okay, and this is the condition required for oscillators, and this we will do discuss in our next unit. Okay, and fourth case is if mode of a beta is much greater than 1, in that case what will happen, this 1 can be neglected in comparison to a beta. So this voltage gain will be, a will be this value, a over minus a beta, a will get cancelled out, then this will be minus 1 by beta. Okay, so that means the af depends only on feedback network, and okay, this gain will depend only on feedback network, and it is case of large negative feedback. Okay, and then this is the theory of the feedback. Then we come to uh, another important part of this topic, which is various types of feedback circuits. Okay, there are basically two uh, feedback circuit. One is voltage feedback circuit and other is current feedback circuit. Okay, because only two things we can feed to the input, either we can feed voltage or we can feed current. Okay, so broadly there are two, but within those two, say like voltage feedback circuit, again we can feed that output voltage to the input voltage in two ways, either in parallel or either in series. Okay, so depending on that we have further two categories. Okay, so the voltage feedback circuit is that in which we feedback fraction of the voltage to the input circuit. Then also it can be of two type, one is voltage series feedback, other is voltage shunt feedback. Okay, so first we will discuss voltage series feedback circuit. In voltage series feedback circuit, as you see this diagram, this one, which is very important. So first thing you need to remember what we are feeding to the input. Okay, as its name suggests, it is voltage series feedback circuit. So first thing is we are feeding voltage. Okay, so what we are doing in the circuit, we take voltage. Okay, and whenever we feed voltage, we do remember, we always has to remember voltage will always be picked up in parallel, because in parallel combination voltage remain the same, and current will be same in the series. Okay, so in parallel combination we have picked up the voltage. Okay, this voltage means this parallel in the output will picked up. Okay, and through this feedback network which will decide what fraction of voltage will be fed to the input, and this we have connected in series. Okay, the voltage which we picked up in the output, okay, fraction of that voltage is connected in series to the input. Okay, that's why this name comes voltage series feedback circuit. Okay, I hope आपको समझ में आया होगा कि मैं क्या कर रहा हूँ. Okay, so voltage, that means we picked up voltage in the output like this. Okay, whenever voltage, that will be picked like this only. Okay, and the fraction of that voltage will be decided by this feedback network, how much, but we have fed that voltage in series. Okay, so in series it will go like this. Okay, like this you remember. So this circuit is known as voltage series feedback circuit. Okay, now we come to other part, which is voltage shunt feedback circuit. Okay, which is this one. So again the basic thing, we are feeding voltage. Okay, so same way like upper diagram. Okay, this thing will remain the same, and this feedback network will decide how much fraction we feed into the input. And then we have this shunt. Okay, the voltage which we, the fraction of the voltage we which we picked up in the output, and which we want to feedback to the input circuit, but it is in shunt form. Okay, shunt means parallel. Okay, so this is the way we how we represent that parallel thing. Okay, so this circuit will change if you compare this with the upper diagram. Okay, so there we have used this will there we have used series voltage series, and this combination voltage shunt. Okay, and this is how this diagram gets changed. I hope you do understand this diagram. Okay, so these are the two types in voltage feedback circuit. Okay, then we have another part which is current feedback circuit. Okay, so in this circuit where we feed voltage, okay, which is proportional to the output current. Okay, we do feed voltage only into the input. Okay, okay, but that voltage will be proportional to the output current. Okay, so that circuit is known as current feedback circuit. Here again, in this current feedback circuit, again we have two types of feedback circuit. One is series current feedback circuits, other is shunt current feedback circuit. Okay, so as this name clears, we are using current feedback circuit. Okay, so here the output will be like this. The output diagram, the diagram in the output will be like this, because we are feeding the current. Okay, and current will be same in the series only. Okay, so that's why we picked up this way. This output current which comes out through this amplifier is fed into series to this feedback network. Okay, and corresponding to this current, a fraction of voltage, okay, is feedback in the input, and that feedback is in series. Okay, whatever circuit name is, series current feedback. Okay, so this is how we feed that voltage in series. Okay, this we have already discussed in upper diagram. Okay, so this diagram will be look like this. Okay, the only thing you do not confuse with its name. Okay, earlier name was voltage series and voltage shunt, where we use that term voltage. वोल्टेज की टर्म को हमने पहले यूज़ किया था, जो कि हमारी आउटपुट में थी. यहाँ पर हम सीरीज करंट और सीरीज शंट लिख रहे हैं. ओके, सो दैट करंट थिंग इज द आउटपुट. ओके, उसको हम बाद में लिख रहे हैं. ओके, सो दीज आर जस्ट नेम विच इज जस्ट गिवन रैंडमली. ओके, अगर आप कंपेयर करो तो जो वोल्टेज सीरीज वोल्टेज शंट लिखा था, तो अकॉर्डिंग टू दैट दिस शुड बी करंट सीरीज एंड शंट करंट करंट शंट होना चाहिए था. ओके, बट दिस इज हाउ इट इज़. ओके, वी कांट हेल्प यू. ये नाम ऐसे ही रखे गए हैं, बट यू नीड टू रिमेंबर वेन एवर इट्स करंट. ओके, सो करंट इज पिक्ड अप लाइक दिस इन द आउटपुट. ओके, and the corresponding to this current, a fraction of voltage is feed into the input but in series. Okay, and this is how we made this series connection. Okay, I hope you understood. And similarly, then we have other thing which is shunt current feedback circuit. Okay, and for this the diagram is like this. uh, Again, you need to remember, because we are talking about current which we are feeding, corresponding to which we are feeding that voltage. Okay, so this diagram output thing will be look like this. Will pick up a current, and corresponding to this current will have that feedback voltage. Okay, and that voltage is feed in shunt connection to the input. Okay, and shunt connection will be like this. This also we have discussed in our now, voltage shunt feedback circuit. Okay, and this is how we'll have this diagram for this circuit. Okay, so these are the four different configuration and their circuit diagram, and these are very important diagrams. And in our next lecture we will do discuss all these four circuit diagram, and we will calculate all the advantages and disadvantages of this feedback circuits. Okay, and I hope you have understood this. If you have any query, then you are welcome. Thank you.